Okay, and thank you very much for your time. Brian is going to give you some tips and tricks, and then we'll continue on from there. So you'll see more of me later.
Hello, everyone. My name is Brian Fukushima, and I'm currently a creative specialist at Foundry, focusing on Katana. Tonight, I'm going to show you a few things that you can do to start to modify the Katana UI. Among these are going to be shell scripts. So if you just click on this guy up here, it actually saves Python code inside of it. So if you just had Python down here that you wanted to do whatever with, you could save it inside of a shell script for reuse. We have this little guy called GSV popup, which is going to display our graph state variables for easier use. So if we want to change our light rig, we could just come down and change that. Secondly, we'll be going over layered menus. Layered menus, a great example of them is how you create nodes inside of Katana. So when you hit tab and type in the node name, what these layered menus are doing then is they're displaying a text-based value to the user, and once the user selects this text, it runs a function in the background to do something. For example, with the node creates, it's actually doing a nodegraph API.create node prune at the root level. One great example of this that's implemented into a lot of shading engines is one to create a shading network for you automatically and import those shading nodes. So for 3-to-light, we have one, and we can just create our material node for our 3-to-light material. And it's actually going to create that for us with the original network and plug our material in to a network material rather than having to go through the multiple button clicks to set this up manually every time. The third one are tabs. And tabs are a very core feature to Katana. What tabs are essentially pretty much everything that information is displayed inside of Katana. You can create your own. For example, I've created one called TDL make. For those of you who don't know, TDLs are 3-to-light's proprietary file format that has their own little special sauce behind it to run better with 3-to-light. So if we just look inside of this, what this guy's going to do is essentially grab a directory, list all the files that are images inside of that directory. The user can then select whichever ones they want and convert them to TDLs for future use without having to leave the application. Finally, we'll push it a little bit into super tools, which are essentially a group or macro node, which has a Python wrapper on top of it, so that when you hit a certain portion in the node graph, it can do this Python operation and remove these button clicks from the user and return them to getting back to creating the shading network, rather than doing all the setup work. We have this one called input sequence if we dig into it, and this guy is essentially going to look for a graph state variable change, and then it's going to create a subdirectory inside of here. So if we just go to our project settings and create a new shot, say shot 25 comes up, it will automatically add that group node for us. We can further dig into these subdirectories and start to add more users, and those users would automatically be populated. The ramifications behind this, for example, in sequence-based lighting, if you had a Gaffer 3 up here and then live groups with multiple Gaffers referencing the original Gaffer, can start to create an organized data structure for your users inside of a production environment. With that being said, now that you have a better basic knowledge of some of the ways that the UI can be adjusted inside of Katana, let's dig into what we're going to be presenting. And this is essentially a mock look dev and mock pipeline, if you will, just to kind of give these tools a little bit more real applicability. What some of these tools are, for example, is we're starting off with super tools, and then we'll work our way down from the top of the network all the way down to the bottom. This mock look dev template is built off a few different principles. The first one being returning the user back to getting into the shading, rather than doing a lot of setup work and creating cameras, importing assets, all that stuff that they don't necessarily need to do to create a shading network. The second one is scalability. What I mean by scalability is that this template will have the ability to throw any amount of assets at it, and then you can bake a look file out for all of those assets or a singular asset. This means that this mock template could handle anywhere from a single prop up to a hero character, to an environment, to a crowd. And how it accomplishes these things are through a few fundamental things inside of Katana. The first one being the fact that every single node inside of Katana actually has a parent. So even all of these nodes at the topmost level of the node graph have a parent called the root node. And the root node provides us a very unique way of setting global parameters inside of a Katana scene. For example, I've created these parameters called asset globals, and then I have a publish directory that we're going to. So I could queue that from anywhere inside of the scene if I just create a new group node. And I can create some new expressions on it. And we can actually just look up to the parent level and do. And as you can see, we're now grabbing that from the root node just with a referenced expression. The second way that this template is going to accomplish these things is through graph state variables. And for those of you who don't know, graph state variables are essentially environment variables inside of Katana. And this provides a very powerful concept, is it's going to allow us to switch the network in the background without the user having to go in and fiddle with it. Rather, they can have the graph state variables displayed at the topmost level to themselves for a slightly nicer UX experience. However, with how graph state variables currently sit, this isn't really the nicest way of viewing them, right? We only have like 4 or 5 that are actually displayed in this bar, and we have about 8 down here. So that's not necessarily ideal, so we can start to develop new ways of handling this to give the artist a better user experience. The first one I showed off earlier was the little pop-up widget. And so we can start to change these graph state variables. I'm just gonna cue this. The second way would be through a heads-up display. And this is going to manipulate how tabs in Katana actually work, as each one, that's a horrible thing to look at, as each tab is actually based off of a Qt framework, which means that it has a layout inside of it, which means that you can insert more widgets inside of that layout. So what we can actually do is look for a global event and then queue a heads-up display to start to change our graph state variables for the user. For example, we can just start changing our light rig around. However, this runs into the same limitation as the top bar does, in the fact that the more graph state variables we go, the more we start to run out of space. So the most scalable option that I'm presenting today is through a layered menu. Unfortunately, layered menus can't call layered menus, and a graph state variable change would require 2 depths to that. So in order to do that, what you'd have to do is, if you wanted to say change the asset, you'd have to select which graph state variable you wanted to change, and it's actually going to store a dummy parameter on the root node to be called by the second call to the graph state variables to then change the asset. Hopefully it'll go. Oh, I know it's wrong. Anyways, moving on. That was not a good example of how that should work. So layered menus can be scaled a little bit better, and so we could have changed that. There it goes. But however, this gives you another button click that you don't necessarily need as you're going in and out of this layered menu due to a limitation. So you can start to manipulate how those layered menus actually call their function callback. And you could put a Qt widget inside of that and then dock it into the node graph so that you can remove this function. So if we wanted to change that asset again, we could do that, and then it docks this Qt widget on the bottom for us, which allows us to easily change our asset again. Now that you have a better understanding of this template and kind of some of the building blocks and principles around it, let's dig a little bit further into it and see everything that's going on. We've created a few little black boxes that the artists aren't necessarily going to touch, but has some stuff going on in the background that the artist will change with graph state variables. The first one being this import assets. This guy here is very similar to the importomatic node, and the fact that the importomatic, once you start adding caches in, just going to add a few of the same ones so that we can look at the internal structure. And we can start to dig into the importomatic and just see what's going on. And it has a group node with an alembic node inside of it, and then it merges these all back together. However, this may not necessarily be what we want to happen inside of our import of assets. So I've created this one called a super tool called import assets, which is going to handle things a little bit differently, but very similarly. The first thing it's going to do is the same thing as the importomatic and bring in all of our geometry caches with the alembic in. It'll then merge them together. Where it starts to differentiate is with these variable switches, which is going to allow the user to start changing their variables. For example, we can start changing the asset and viewing all of our assets at once if we wanted to look at this large environment in the round with this, where is it? Special all parameter. So now, as you can see, we've actually loaded in all of our assets. However, right now they're all on top of each other, but we'll dig into this a little bit further. And then if you select a singular asset, it's going to go the other way and just display that singular asset. This allows us to flow into the next node, the setup master bake, which is going to kind of manipulate the look file bake process to allow us to bake out this singular look file for multiple assets or a single asset, along with setting up a few objects if there are multiple objects in the scene in an array function. So if we dig into this guy, what we actually have is on the left branch for a singular asset, and on the right branch for the master all asset. And so the first thing we really need to do is that if we take a look at this asset here and the attributes, you'll see that the bound attribute is actually global and is being inherited by this top level. However, we're going to remove this top level as part of this relative look file bake, and then bake the look file on the asset. So we now need this bound to be on the lower level. So we're going to set that with an op script. After we set that with the op script, we're going to remove that item from the hierarchy so that it's now set up to do lookdev in the fashion that we spoke about earlier. We're then going to go with our variable switch to switch based off of if we want to do a lookdev test or if we actually want to create our shaders. The reason that we're going to do this is so that later on we can bake out the look file, bring it back in, and actually QC this look file based off of what we plan to pass off to lighting. Where it gets a little bit more interesting are with these array functions. So let's just take a look at this and see everything that's going on. So what we can now do is turn on the array, change it to yes, and we need to resolve further down. And as you can see, we now have multiple objects. Actually, I'm going to resolve all the way at the bottom. So we can do this and this. So now, say for example, you have this array, you have this instance that you want to use multiple times, but you want to put a variation shader on it. You can then come in here and start changing the number of items that you actually want in your array, and it's going to automatically set them up and align them for you. The amount of button clicks that a user would have to go to set this up manually every time could be quite enormous when you consider the ramifications of that. For 35 items in an array, the user would have to create 35 transform 3D nodes and then translate them all, which would be somewhere around like 100 plus button clicks. And then if you want to do any changes, you have to do all those button clicks over again. This same feature works if you wanted to go to the asset all and look at all of your assets in the round to have them automatically laid out. Let's just go expand all. Now, moving down, and this is where we start to get out of our black boxes and into what we would like the user to actually start clicking on and doing, which is the shading. So if we look at some of these down here, this is just a bunch of macros that I've created that have shading networks inside of them. And in order to create the base macro, I've created one called dlmat, which has a few things on top of it. But the entire workflow behind this is that if you wanted to create a shader, you could start from your shader library. And that shader library could be created in a tab to be viewed back to the user. So what we're looking at here is just a simple reference sphere and then the textures that are rendered out at the end of that network. If we wanted to bring these guys back in, such as this one wall mat, we could just right click and import the shading network, which would drop the macro back in. The other option we can do is if we want to do a simpler change, or if we're working with look files for materials, we could right click and import the look file back in. It just depends on how you want to handle this workflow at that point in time. These nodes go a little bit further in terms of how they are handled, in the aspect that they have a few options visible to the top level for the user. These options then go into the macro, and what we have inside of here with this shading network is we have files coming in on the left, isolation maps coming in on the right. So now you can read this network in an old school map of longitude-latitude format. This eventually spills down into a material and then into a network material. We'll get into this switch in a second, and then merge back in with the master branch of our node graph. We can then use collections to assign the material sign and the object settings to this. And then this guy under here, this publish group, is what's going to happen when we hit publish. And inside of here, we have just a giant, nasty thing of nodes that's going to do stuff in the background. But what will happen is that it will render all of these guys out, which is the reference sphere, the end of the textures, etc. And that's what is being displayed in the shader library, along with exporting the macro for the material and the look file for that material. So let's look at something a little bit more interesting in terms of what this material switch is actually doing and being displayed. Change over to a singular asset. That'll do. Turn our array off. All right, so now we're back to a single asset. However, say that you're doing lookdev and you want to start looking at the raw outputs of this. You can start to do that with a graph state variable change, just based off this shader one. So we have a few called primary, which is our actual shading network, and a few other ones such as diffuse. Or you could look at your spec-R. Or even if you have a lot of assets and you're not sure about these UVs, you could put in a UV function in there just to start to make sure that your UVs are actually working and what they're at the scale that you currently expect. Where the user starts to get more control over this is with the selection mode, where they can select any portion in their network and it's going to render that out for them. through a hotkey click. And how this is working, come on, let's see if it works. Doesn't seem to like me right now. Oh, I know why. We're in the wrong network. Cool. And so what is actually happening is that we have a tab that's doing something very hacky, and it's looking for a hotkey press in the node graph. And then it's setting some functions to allow the user to just skip around their shading network to try and debug it in real time. And what's happening with that is that when that hotkey is pressed, it's going into this super tool over here, setting the node name on top of it, and then inside of it, it's actually switching between the ports depending on if it gets a float or a color. As if you plug a float into a color, it's probably not going to have nice results with that. As we continue to push down, that's where we start to end the look dev for the user. And the user can start going into these more black boxes again. We have one called the Turntable Node. And what this guy is essentially just another group that's a black box to the user that's going to have a few functions inside of it. The first one is the look dev QC, which if we dig in, is just on the left branch bypassing, and on the right branch, we're assigning our look file and then resolving that look file from the start of the look dev and bypassing all of our shaders just so that we can do a simple QC check inside of Katana. We then have the Gaffer 3, which just has an environment light on it. And it's going to switch this light in a very simplistic fashion with just an expression that's going to look for the graph state variables, as those are just on the root node, so we can get the parameter and change it based off the light rig. And that's how we can simply change our light rig quite easily to, say, overcast. And then change the shader back to primary. And as you can see, our light rig is being changed just based off of this name change for the path to the TDL file that's being loaded into the Gaffer. Where it starts to get a little bit more interesting inside of here is the turntable setup, and there's some basic stuff up here. This is essentially the camera create with geometry. So you have a camera create, adding your geometry over here, such as your spheres or your reference plane, and then creating those materials, such as a gray mat, pro mat, or the HDRI mat, assigning those materials, doing some object settings to them, depending on what you want visible or reflective and whatnot, and then just merging it back in with the master branch of your network. The interesting portion of this node is the frame object one, as we don't necessarily want the user to be framing the camera every single time for every single different object, as that takes them away from actually doing work, right, and creating these shading networks. So if we just have a quick look at this wireframe and expand our camera, we can see that our camera starts at origin with a slight rotation down. And we need it to automatically frame this object no matter what it is. The first thing we can do in order to do this is use an OP script to kind of find the bounds of the Y, to put this camera somewhere in the Y value that we think is consistent in terms of percentage. I've chosen halfway for this op script. And as you can see, the camera will now move halfway up just by reading the bounds of the object. The second thing to do to frame it is with a Dolly Constraint. The Dolly Constraint is going to push the camera out and automatically frame the object. So now we can switch between any object, and the camera is going to automatically frame every single time, thus automating this process slightly more. This even works, as you saw before, if you have the asset all and anything in an array. Oh, we just have to go to the right side of it. And it would automatically frame all of these objects for you. The reason why we have a few variable switches underneath it is just due to the location of the bounds is going to change based off of if it's a singular asset or multiple assets. We then go into some other basic stuff, such as rotating your geometry and rotating your lights, which is usually nice for look dev turntables. And then we're just going to move the camera back an arbitrary amount, just to make sure our objects are framed. At this point in time, your artist would be hitting render. And say, for example, that now that they're done with this, they're happy with the look dev, and they want to bake out this look file. And so that's where we go over to the look file bake side, which just takes one little parameter, a button that you click. Easy. But how does this button actually work? Well, what's going to happen when you press this button is that it's going to look into the published directory, find the latest version, update that version, and then bake a look file out to that version. So if we look inside of it, we have a few variable sets which are going to change the graph state variables at that given point in the graph, just to make sure that our network is actually properly set up how we expect it to do for this kind of master bake process that we're doing. The first one we're going to do is making sure that we're actually baking out our shaders instead of our look dev or our look file. The second one is to make sure that we're on the asset all, as this would grab all of the assets to ensure that they're all in there for the bake. And the third one is to make sure that our shader is set to the primary one so that we're not rendering out any sort of tests. So if everything works as expected, you can hit the little button, and then our graph state variable for the look file would be updated to this 129 now. And now if we change our look dev over to our test look file, let's just look at any one of these and look at the attributes. We can see that our look file has been attached on automatically, our materials have been resolved, and even the collections that we've created for these materials have been passed off with this look file. So now when we render it, we can get a very quick QC check. However, this might be better done with a pipeline, and you can send it to your local farm to be done with a look file bake. Unfortunately, I'm limited to a single computer at this point in time, so I don't necessarily have that power. I hope it works. Yay. In conclusion, though, let's go like this. In conclusion, inside of Katana, there are a lot of different things that you can do with the UI, and not all of them are the best, but there are some very cool things that you can make, as long as your artist, as long as they're very usable for your artist and can kind of create the amount, reduce the amount of button clicks that your artists actually have. Thank you.
If you want to know about that little Easter egg, you can ask Brian later.